today we're going to be introducing the concept of algebraic vectors. We just came from geometric vectors where we did drawings, where we did tip to tail, and we drew vectors out. Now we're going to be solving these things not geometrically. With a protractor and a ruler, we're going to solve them algebraically. So what I want you to do right now, we're going to zoom in real quick and understand that whenever you have a vector, it can be rewritten as an ordered pair. All right? So vector P1, P2 is written as, it's kind of hard to see right here, but there is, this right here is the vector symbol for the ordered pair. So in your journal, you want to make sure that you draw these nice little arrows at either end. It's not a parentheses, all right? It's a vector symbol for the ordered pair. So what we're going to do right now is we're going to go ahead, we're going to do problem number 1. So there's problem number 1. We have an ordered pair 2, 4 and ordered pair negative 1, 3. So I'm going to go to some graph paper right now. I'm going to make a nice Cartesian plane. That's not nice. Alright. Alright. Now, we have A, which is at a 2, 4, and we have B, which is at a negative 1, 3. Alright? This right here, the A is where the initial point is. That's where the vector begins. B is referred to as the terminal point, where it finishes. Okay? So right here, A is going to start at 2, 4, right here. So put a point right here in your journal. Call that A. And then we're going to do a terminal point right here at a negative 1, 3. That's where your vector is going to finish. So right here, we're going to draw a vector. It's going to start at A, and it's going to finish at B. Now, if I want to find my vector ordered pair of vector AB, A is up front. Remember, that's the initial, that's the terminal point. That's why it's written as vector AB. I want you to understand vector AB is different than if I said vector BA. They'd be two different vectors, okay? I'm going to erase that right now so don't get confused. Now, what we have to do is we're going to take x2 minus x1, comma, y2 minus y1, and that's going to be our ordered pair for our vector. So we're going to label this. This right here is your x1. This right here is your x2. Why is this your x1? Because you're dealing with the initial point. Why is this your x2 right here? Because that's the terminal point. This will be your y1. This will be your y2. So let's go ahead and plug these in. What is my x2? My x2 is a negative 1. I've got to take away my x1, which is a positive 2, comma. Y2 is what? Is the number 3. Minus, what is my y1? My y1 is a 4. Right here, negative 1 minus 2 yields me a negative 3. 3 minus 4 yields me a negative 1. This right here is my vector ordered pair for vector AB. What I'd like you to do right now is put an arrow and write this represents what's known as your horizontal component. That's your horizontal component. This right here represents what's called your vertical component. Okay? There we go. Vertical component. All right. On your graph paper that you have, why don't you guys right now realize, look, what's your vertical component? How much does that go down? Goes down what? Negative 1, right? It goes down negative 1. Well, how much does it go to the left? It goes to the left, negative 3. Does everybody see how this is your horizontal and this is your vertical? All right. Now, once you have your horizontal and your vertical component, This is how you find what's known as your magnitude. This is very easy. Magnitude. Your magnitude will always equal the square root of the change in your x squared plus the change in your y squared, which means the change in your horizontal component squared plus the change in your vertical component squared. Well, what is the change in our horizontal component? It's a what? -3. We're going to square it. What's the change in our vertical component? -1. We're going to square it. What's -3 squared? 9. What's -1 squared? 1. 9 plus 1 is 10. The square root of 10 is the exact answer for the magnitude, but that's approximately equal to a 3.08 or a 3.1 if we round to the nearest 10. So your magnitude is 3.1 approximately for problem number 1. We're going to do this exact same process for 2 and 3. Go ahead and do that now. So, in review, here are your two answers. It asked for the vector ordered pair, which was a -3, -1, and it also asks for the magnitude for your resulting vector, and the resulting vector's magnitude is a 3.1. So that right there is your answer for number 1. All right, let's look at number 2 right here. All right, we'll call this x1. We'll call this x2. y1, y2. Just remember, your vector is going to be x2 minus x1 and y2 minus y1. This will give you your horizontal component. This will give you your vertical component. What is my x2 value? 5. Minus, what is my x1 value? 4. So 5 minus 4 is 1. So that is my horizontal component, a positive 1. Now, let's look at my y2. My y2 is a -5. Minus, what's my y1? -2. What happens when you have two negatives next to each other? Changes it to a plus. -5 plus 2 is a -3. This is your answer for your ordered pair for your vector of A, B. That's your ordered pair. So that's not the magnitude, but wait a second. What was our magnitude last time? Magnitude last time was what? 3.1. What's the change in your x, -3? What's the change in your y, -1? This time, you got a 1 and a -3, but you know what? When you square those and take the square root, you end up getting the same exact magnitude. It's just going in a different direction. Okay? It's just going in a different direction. All right, before we move on, I want us to look at our problem that we did geometrically on our last assignment where we had the stump problem. So right now, see the stump problem right here? What I want you guys to do in your journals, right now I want you to make 3 vectors right now. Okay? We're going to change colors here. I want you to have a purple vector going up. You don't have to have purple, I'm just making my purple. All right, I'm going to have a blue vector going to the right, and I'm going to have an orange vector going down as best as I can. Okay. So right now, I'm just redrawing it. I'm going to call this one. This is going 60 newtons going up. This one is going 35 newtons going to the right. And then right here, this one has a 60-degree angle right there. And that is going 40 newtons going down in this direction. So let's talk about some ordered pairs we can have for a vector. What's the change in the x for this? It's not going left or right, it's going straight up. So the change in the x is 0. How far is it going up? It's going up 60. So your vector ordered pair for the purple vector would be 0, 60. Look at the blue. The blue is going which direction? It's going to the right. How far is it going to the right? It's going 35. How much is it going up and down? 0. So its horizontal component is 35, but its vertical component is 0. The last one's the trickiest one. Because it's going what? It's going to the right, but it's also going down. You guys see that? I'll make dotted line here so you can see it. See how it's going? It's going where? It's going to the right, and it's going down. But if we form a right angle, that's 60 degrees, that's 90, this is 30 degrees. What kind of triangle do we have? We have a 30, 60, 90. X radical 3, 2x. This is side x. This is your 2x side. This is your x radical 3 side. What's our longest side? It's always across from the 90-degree angle, right? So what's our longest side? 40. Okay? Which means if that's 40, what's our shortest side? 2 times what is 40? 2 times 20. Alright? So this, I'm going to make a triangle so you guys can see it. If I were to recreate this triangle right here, everybody see that triangle? If that's 40 right here, that means this is 20. This is always half of it. This will be 20 radical 3. So our 60-degree side is 20 radical 3, which is directly across from the 60-degree angle. You can see how that's across from the 60-degree. Just like this 20 is across from the 30-degree angle. Now, what's my horizontal component? It's going this direction, how much? It's going this direction, 20. What's my vertical component? Is it going up or is it going down? It's going which direction? From the stump, from right here. It's going down. So you actually have to put it's going down 20 radical 3. Now, my final result is going to be in red. Okay? My final result is going to be in red. So check this out. What is 0 plus 35 plus 20 if I add all of these vectors together? That's a total of what? 55. What is 60 plus 0 minus 20 radical 3? That'll be 60 minus 20 radical 3. Now that's approximately equal to 25.4. And how do we find our magnitude? This right here is our ordered pair for our vector, right? That's our vector ordered pair, right there. How would I find my magnitude? I would take the square root, and I would put 55 squared plus that 25.4 approximation. When I take the square root of that, I get 60.6, and I would label it newtons. And our answer for that geometric vector problem ended up being 60.6 when we drew it out on the last assignment. Okay? Did we do any drawings right there? Yes, we did drawings right here, but technically, if I look at this, if I wanted to do this algebraically, I could write the ordered pair for that. That was what? That was 0, 60. This was 35, 0. This one was trickier because it actually had what? It had a horizontal component and it had a vertical component. Okay? All right. What is vector W by itself equal to? What's vector W? Negative 3, 5. Okay. Minus 2 times, what's vector V if you look at your paper? What's vector V? 2, negative 1. Okay? Alright, right here, this is just a scale. So I'm going to scale this by 2. So what is 2 times 2? That's a 4. What's 2 times negative 1? That's negative 2. I'm going to keep the minus sign, just bringing down the minus sign. And right out in front, I have a negative 3 and a 5. This is where you got to be very, very careful. I'm taking the negative 3, and I'm taking away 4 more. That's going to yield me a negative 7. Taking 5, I'm taking away a negative 2. 5 take away a negative 2 is 7. Your final answer is negative 7, comma,